Hello, welcome to lesson 3A-6. We're going to focus today on perfect square polynomials. Our learning target is going to be the eigenfactor perfect square trinomials. To do that, we need to start out with a little bit of vocabulary. We're only going to have one word to define today, so go ahead and turn to your glossary and add this word into the appropriate section. So a perfect square trinomial is a trinomial that factors into two identical binomial factors. That means that both factors, when we break this down, are going to be exactly the same as one another. So take a minute and go ahead and copy that into your glossary, and then we'll go ahead and jump into some examples and some notes. All right, so we talked yesterday about the difference of perfect squares, and we talked briefly about what a perfect square was. Today, we're going to talk about perfect square trinomials. And in a perfect square trinomial, we have a couple conditions. We're always going to have the first and the last term that are perfect squares. That means that if we take the square root of those numbers, we would get a integer response. We would get something like 49 would be a perfect square because it breaks down into 7 times 7. Whereas the square root of 2 is going to give us some sort of decimal. That's not going to be a perfect square. Our second condition is that the middle term is 2 times one factor from the first term and one factor from the last term. So if we can check off both of these requirements, then we know that we have a perfect square trinomial. So let's go ahead and take a look at an example. Alright, so in example 1, we are given x squared plus 12x plus 36. So let's first break down and look to see if we meet our requirements. So if I go back and review, we have to have the first and last term being perfect squares. Alright, backed up too far there. Alright, so let's look at the first term, x squared. X squared could be broken down into x times x. That's the same factor on either one, so that's going to be a perfect square. So our first term is going to be a perfect square. Let's take a look at 36. 36 can be broken down into 6 times 6. So I can go ahead and say that my first condition is met. The first term and the last term are perfect squares. But that's not our only requirement. We also have to have a middle term that is 2 times one factor from the first term and one factor from the last term. So what I'm going to do is I'm going to take one factor from my first one. I'm going to take an x. And I'm going to take a factor from the second, well, technically the third term, but our other perfect square, which would be 6. And when I multiply those together, I get 6x. Now remember, the middle term is 2 times one factor from the first term and the last term. So we've multiplied those together, and now we have to multiply that by 2. So 6x times 2 is going to give us 12x. And we can see that that is actually what we have on the inside there. So we can check off both requirements that this is a perfect square trinomial. Now, how we can use this. We're going to break it down into two sets of parentheses. And at the beginning, I'm going to put the perfect square for my first term. So I broke this down into x times x earlier, so that's going to go here and here. And then my second term, I broke it down into 6. Alright, so I'm going to see that x plus 6 is going to be my first factor, and x plus 6 is also going to be my second factor. Now, in order to write this a little bit neater, since these are the same thing, multiplied together, we can shorthand this as saying that this is the same thing as x plus 6 squared. Alright, and if we did want to check our answer, and we wanted to go ahead and multiply this out to make sure our answer did indeed match, we would take x times x and get x squared, and then we would take x times 6 and we would get 6x. Then we move to the inside and distribute that 6. We would get a 6x there, and we would get 6 times 6, which would be a 36. So I'm going to end up with x squared plus 12x plus 36, which is exactly what I started with up here. So we can see that this is a perfect square trinomial, and it is going to factor down so that each factor is x plus 6 times x plus 6. Alright, let's go ahead and take a look at our second example. So if we are looking at our second example, we are given 4x squared minus 24x plus 9. Alright, so I want to go ahead and check my circumstances again to see if I can check off those two conditions. Remember, the first and last terms need to be perfect squares. If I look and break this down, I can break this down into 2x and 2x, which are the same, so that's going to be a perfect square. Now I'm going to break down the last term, but I want to make sure I pay attention to my sign this time. I can see that the sign of that second term is going to be negative. So when I break 9 down, I'm going to have both of these negative so that I can have a positive product here and a negative sum here. So normally I would break down 9 into 3 times 3, but since I know that I have to end up with a negative, I'm going to break it down into negative 3 times negative 3, which is still a perfect square since I have the same number multiplied by itself. So we are still able to meet the first condition. The first and last terms are perfect squares. Now the middle term has to be 2 times one factor from the first term and one factor from the last term. So I'm going to go ahead and do this all in one step this time. I have the 2 times that I have to have from my stipulation, a factor from the first term, which was 2x, and a factor from the last term, which is going to be negative 3. So I multiply these together, and I get 2 times 2x is going to be a 4x, and a 4x times a negative 3 is going to be a negative 12x. So for this to be a perfect square, I would have to have a negative 12x here. In this case, I do not have a negative 12x, so this is not a perfect square trinomial. Not a perfect square trinomial. So I'm not going to be able to factor using this method. And actually, this particular problem is going to be pretty tricky to factor. So we're actually going to need a tool that we haven't talked about yet that we're going to talk about in 3A-10 called the quadratic formula. And we'll get to that in future videos. But for right now, in this lesson, we're focused on 1, identifying whether it is a perfect square trinomial, and then 2, if it is, going ahead and factoring it. Since this is not a perfect square trinomial, we are going to leave this alone for now, and we're just going to move on to our next example. Alright, so in this example, we are given x squared minus 40x plus 50. Now, I want to go ahead and check my first requirement to see if both of the first and the last term are perfect squares. Now, I'm looking at my first term, and I'm seeing 8x squared. I know that x squared can break down into x times x, but I'm not sure that that 8 is going to be a perfect square. If I look at 8, I could break that down into 4 times 2, or 8 times 1. But those are my only two combinations of factors. And 4 times 2 and 8 times 1, those are not perfect squares. So right now it's not looking like this might be a perfect square trinomial. One thing I want to go ahead and do is go ahead and look at the rest of the terms though. I have an 8x squared, I have a minus 40x, and I have plus 50. So what I'm seeing here is that all of these terms are even, which means I know I'm going to be able to pull out a greatest common factor of at least 2. So let's go ahead and see what kind of greatest common factor we can pull out and see if that might leave us with something that is a perfect square trinomial. So we talked about 8 being able to be broken down into 4 times 2, and 4 being broken down into 2 times 2 further. 40 we could break down into 4 times 10. 4 again is going to be 2 times 2, and 10 is going to be 5 times 2. And if we break down 50, we're going to have 5 times 10, and 10 breaks down into 5 times 2. So just to give me a little separation there so I can see which one's which, we want to look for a greatest common factor. Now I have a 2 in this one, I have a 2 in this one, and I have a 2 in this one. Now that looks like it's going to be all I have in common, so I know that my greatest common factor is going to be 2. So I'm going to pull out that 2 and see what that leaves me with. So if I pull out a 2, I'm going to have a 4x squared minus 20x plus 25. That's just dividing all those numbers by 2. So let's reevaluate now and see if this is a perfect square trinomial or not. Alright, So to do that, we want to go ahead and break down our first and last term. And we can see that this is going to break down into 2x and a 2x. And I'm going to break down the 25 as well. I want to pay close attention to my sign of the middle term. I have a positive last term and a negative middle term. So that means that my factors are going to have to both be negative so that I have a positive product but a negative sum. So I can break 25 down normally into 5 times 5, but since I need that middle term to be negative, it's going to have to be a negative 5 and a negative 5. So I actually do now meet my first requirement, is that the first and the last term have to be perfect squares. Now, to meet the second requirement, I would have to have this middle term, the negative 20x, be 2 times one of the factors from the first term and times one of the factors from the last term. So if I do that, I'm going to get 2 times 2x, which is going to be 4x, and 4x times a negative 5 would be negative 20x. So we see that we actually do meet that requirement. So this is going to be a perfect square trinomial. Now, we do have to remember that 2 that we factored out, our greatest common factor that we had up here. We can't forget him. Alright? But we're also going to go ahead and factor this into a perfect square trinomial. So we would have a 2x to lead each term, and then our second term in each binomial would be minus 5. So when we finally rewrite this for our final answer, we would have 2 times 2x minus 5 times 2x minus 5, which we can simplify as 2 times 2x minus 5 squared. And that would be our final answer. Now, just want to go ahead and point out the pattern one more time. In a perfect square trinomial, a squared is going to be a square of the first term of the binomial. B squared is going to be the square of the last term of the binomial. So when we factor it, that's going to match up with that, and that's going to match up with that. And our middle term is going to be twice the product of the first term and the last term. So we would multiply these, the a and the b together, and our middle term would be 2 times that sum. Alright, there is no application for lesson 3A-6. Don't worry, I know you guys have been missing out on the applications. We'll start back up again with the applications in the next lesson. But for now, go ahead and complete your practice and prepare for your mastery check. As always, let us know if you have any questions, and have a great day.